All right, Honors Algebra 2, how are we doing here? This is your first video while I am at home. For Thursday, October 14th, you're going to hopefully only have 3 of these videos. And before we get started, let's introduce our in-house sponsors. Crystal Light Pure Energy, Noon Hydration, and Energy for a Recharge. All right. Cliff Bar, Peppermint Bark, seasonal flavors. Mr. Jack will not say no to these as a Christmas gift. Hint, hint, wink, wink. We're planting 1 million trees. Excellent. Sounds like more game plans in our future. Oh, that's going to have to be edited out. And then, falling down there, Laura Bar, followed by, folks, look at that. A healthy soda. Zevia, 0-calorie soda. No sugar, no aspartame. We got that Zevia leaf. All right, ginger root beer. And extra special guests here today, folks. We have an in-class classroom wow of toddler plush toys. All right, we got the Billikens there at the left. Slew is keeping an eye on this video production there. And starting on Friday, the 15th, we will be brought to you by Knee Rover, Knee Scooter. Yes. Oh, man. A 2-month sponsor. Hopefully not longer than that. Stuart the Minion, my #1 teaching assistant, is currently keeping it occupied for me. Yes, Knee Rover. I will see you hopefully on Tuesday, the 19th, with that. All right, well, 1 year, as you can see, that this was due on October 21st. And, well, believe it or not, it might not be that different for you. I will see you again on Tuesday the 19th, and we will just have a little bit to finish. In fact, the 21st is Thursday, so there is a very, very good chance that it will be due on Thursday the 21st for you. And then after that, week after, we will take that Chapter 3 Part 1 test. This has largely been dominated in years past. All right, so we've gotten a start on this. We've not done the inequality, so here's what we're going to do. I brought out all pin colors for you. And I'm going to finish this up here live. So first, inequality. So unlike page 1, these aren't equations, so make sure you shade correct. Oh, man. Yeah, I did. Okay, good. Make sure you shade correctly. All right, because I used pen here, so if I make a boo-boo. First one in black. And I don't care about the intersection because with an inequality, I have a shading. So I have a region of possible solutions, not just one exact intersection. So -3 is my y-intercept. I go up 2 over 1, up 2 over 1, up 2 over 1. I make a solid line, and then I make a very faint y is greater than. So I'm showing that, you know, it's going up. If you want to make little x's or whatnot to show it's going up, because more is going on here. I'm not just going to go crazy with the shading because we're not done. Then I have y less than or equal to -3/5 x plus 2. +2 down 3, 5 to the right, down 3, 5 to the right. It's another solid line. And where am I going to shade? I'm going to shade below. My answer, my region of feasible solutions is what we're going to talk about here in a few minutes, is where they overlap. So they overlap in this area, so you really need to shade this in. This is the actual solution. All right? This whole region, pick an X, pick a Y, it would give you true, true for both of those. So this whole region is your answer. All right? That is how we answer such questions. So let's take a look at number 1. Y is less than 1/2 x minus 4. That is this dotted one. -4 is your y-intercept. Go up 1 over 2, up 1 over 2, up 1 over 2. Dotted line, and you're going to shade below because it's less than. And then I have y greater than or equal to -2x. So that y-intercept is 0, and the slope is -2, down 2 over 1, down 2 over 1, down 2 over 1. Solid line, greater than means I do shade above. All right? And And where's the overlap? The overlap is in this region right here. That is my answer. All right. In past, I've given them teeth, but, you know, we are live on YouTube, so do not put your favorite English teacher there. Got it? No. All right, number 3. Let's take a look at 3. The first one, black, y less than or equal to x minus 5. Negative 5 is right there. Up 1, over 1, up 1, over 1. Dotted line, not dotted line, solid line, and you're going to shade below. Now, here, that's really nice standard form. So do the cover-up method. 2x equals 6, 3y equals 6. You get an x-intercept of 3, a y-intercept of 2, solid line. Again, y is positive. So if you move the 2x over and divide by 3, the sign's not going to flip. So you can trust less than or equal to. Again, we plug 0 in for x, 0 in for y. You're going to get 0 is less than or equal to 6, which I always want to put false. That's true. 0, 0 is true. And it's below the line, so you're going to shade below the line. Anyway, where's the overlap? Right there. That's your solution. And on number 4, we've got standard form twice. Cover-up method on 1. 8x is equal to 16. Your x-intercept is 2. Negative 2y is equal to 16. Your y-intercept's at negative 8. Now, y is negative here, so you're not shading above. Here's your y-intercept. Here's your x-intercept. If you plug 0 in for x, 0 in for y, you get 0 greater than 16. That is definitely false. 0, 0 is above, or to the left, and I guess technically above. You're going to shade to the right. You're going to shade in that area. On this next one, 5x is equal to 15. X is 3 is your x-intercept. 3y is equal to 15. Y is 5 is your y-intercept. Another dotted line, x-intercept, y-intercept. Plug 0 in for x, 0 in for y. You get 0 is less than 15, and that's true. 0, 0 is true, and it's below the line. Where's the intersection? The overlap. Not the intersection, I guess. Yeah, not the intersection. Overlap is much better. Right there. All right, that's page 6. Then what comes after 6? Well, A does, of course. All right, some Common Core numbering for you. And number 1, y is less than 2x minus 5. Negative 5, and your slope is up 2 over 1, up 2 over 1. All right, it's a dotted line. You're in slope-intercept form, so you can trust. You're going to shade below. Next one is y greater than or equal to negative 3 over 2x plus 1. 1 is your y-intercept. Go down 3 over 2. Again, I don't care where they intersect. I care where the shading overlaps. Greater than or equal to means you shade above. Where's the overlap? Overlap is right here. Big, big jaws again. Over YouTube, we can't send anyone in there. All right, here's the next one. Y greater than or equal to negative x plus 3. Positive 3, going to go down 1 over 1, down 1 over 1, down 1 over 1. Greater than or equal to means you're going to shade above. And then, well, let's get the red one involved here. Y less than 2x minus 7. Negative 7's right there. Up 2 over 1, up 2 over 1, up 2 over 1, dot, 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 dot. You're going to shade below. And where's the overlap? Right there. All right, I believe we have 2 more. Number 1 here, that's lovely slope-intercept form. Positive 4 is your y-intercept. Down 3 over 1, down 3 over 1, dot, 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 dot. You're going to shade below the line. And on this next one, would be pretty easy to move it to slope-intercept form. Then you can definitely shade above the line. Or you can say 3y equals negative 6, y is a negative 2, x is equal to negative 6. All right, x-intercept, y-intercept. Dot, dot, dot. You do shade below. If you plug 0 in for x, 0 in for y, you get 0 greater than -6, which is true. If you move it into slope-intercept form, then you definitely shade above. It's greater than. Where is the overlap? Right there. And lastly, definitely, I've got two here where I'm going to use standard form, use the cover-up method. 6x is equal to 12. X is 2. Negative 2y is equal to 12. Y is a -6. Your x-intercept is right here. Your y-intercept's right there. You're going to have a solid line. Don't shade above. Y is negative. If you move this in slope-intercept form, we're going to have to divide by negative. Flip the sign. If you plug 0 in for x and y, you get 0 greater than or equal to 12, which is false. 0, 0 is above the line, so you're going to shade below. Number 3. 3x is equal to 12. 4 is equal to 12. X is equal to 4. Y is equal to 3. Dot, 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 dot. Y is not negative, so you can trust that sign. Because it's not negative. If you move it in slope-intercept form and divide by 4, the sign won't flip. It'll stay in that direction. You can always plug 0 in for x, 0 in for y. You get the statement 0 greater than 12, which is false. That's false. That's true. Where's the overlap? Right there. All right, all right, all right. That is page A. Page 6 there, done. Let's continue it here with page B. I'm just going to see, do about another 8 minutes here and see where we are. We'll start then the second video. I would tell you then also, again, you're going to be preparing for this test review as I'm gone as well. There are just so many easy ones that you can do and just get prepped for, because we might do that. Shoot, that test might be on the 25th, 2 weeks from when I'm making that video right now. All right. Equation 1, I'm definitely dividing by 5 here. Y less than 2/5 x plus 2. Y-intercept up 2 over 5. Shading below. That's a dotted line. The second one, whoa. Y-intercept of 8. I would not go up 4 over 1. I'm just running out of room. So instead, I'm going to go down 4, 1 to the left. Dotted line, and I'm shading above. Where do they overlap? They overlap right here. Take a look at, let's do number 7 first, because that's very similar. Well, nope, let's just go in order. X is less than 3. That's a vertical line, dotted, less than, at 3. I'm going to shade to the left. Y greater than or equal to -4. That's a horizontal line, solid. And I'm going to shade above. Where do they overlap? In this region here. Y greater than 3x minus 5. -5 is your y-intercept, up 3 over 1, up 3 over 1. A dotted line greater than means I'm going to shade above. Then you have y less than or equal to 4. There's 4. Solid horizontal line. You're shading below. And the overlap, again, this is the answer you got to show. Really darken that. That's the overlap. That's my answer. Number 8. Y less than or equal to 6. There's 6. You're going to shade below. Number 2, y greater than x minus 3. There's -3. Up 1 over 1, up 1 over 1, up 1 over 1. Dot, 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 dot. You're going to shade above. And the overlap right there in the gator's mouth. My wife recently told me that crocodiles, yes, they are the far more vicious ones. Crocodiles, no thank you. So maybe this is a sweet, sweet vegetarian gator. Doesn't want to eat you. All right. Oh, and look at that. We got a page C. Okay, now, so did I make? No, I did not. Okay, just thinking. There. Okay, so 9 and 10, I took a class my last semester at SIU Carbondale before student teaching. It was called linear programming. And on the next pages are different things that we did. It was just working with these big systems, sometimes 5 variables, and you try to break it down. But at a lower level, it's kind of being built from this. So find the coordinates of the vertices of the triangle formed by each system. You know, given constraints, there's a way to maximize profit, minimize costs, working hours. It's a very, very useful course. A lot of engineers are in that course as well. Really enjoyed it. Not only because I got an A, but it was good. It was useful. Good course. So here's number 1. I'm going to graph number 1. -7 is the y-intercept. I'm going to go up. Now I want to know where there's intersections. So I'm going to go up 3 over 1 a bunch. I want to know where there's intersection and I have inequalities. So I'm lightly shading above. So then I have some constraint that whatever variable y is, I have to use 8 or less. Y is less than or equal to 8. So that is in red. There's 8 horizontal line. Now look where I have an intersection there. And I haven't done the blue yet, but that's going to be very important. I should be like vertex 1 actually. That's the first one I'm going to find. All right. I'm going to shade below. Okay, so I've got some overlap here beginning. And then the last one, x plus y greater than 1. Well, I got an x-intercept and a y-intercept of 1. I could just graph that. Or I can say it's y is greater than -1 plus x, which is what I wrote there. So your y-intercept is 1. I'm going to go down 1 over 1, down 1 over 1. So that's my next vertex intersection. So that's actually vertex 2. And this is going to be fine. That's going to be vertex 3. It doesn't matter what you call them. There's 3 vertices because it's a triangle. Because I care about intersection, instead of going down 1 over 1 anymore, I'm going to go up 1, 1 to the left, up 1, 1 to the left, up 1, 1 to the left, do, and boom, another intersection. So, and also it's greater than, so I'm going to shade above. Where do all of the shadings come together? This is called a region of feasible solutions. In this region, I can get something that satisfies all the constraints. Now, if I want to maximize something or minimize something, the true answer is going to come from these vertices. We'll test that later. I'll give you, if we have time, just kind of an example of that. Linear programming. That's what we're doing here. Optimization. All right, so find the coordinates of the vertices formed. So that first vertex is when at 5, 8. And you can tell, so it intersects, that's when the black line intersects the red line. Well, the red line is y is 8. So plug 8 in there, solve for x, you get 5. So I can always check. So my vertices, first one is 5, 8. Let's take a look at what I call vertice 2. That's when the blue and the black intersect. So man, I maybe cannot tell what that is when blue and black intersect. What's 2, -1? And here's why. 2 plus a -1 is 1. Check. If I plug 2 in for x, I'm going to get -1 for y. So I can go back and my original equations or inequalities can help me out. 2, -1. And lastly, where do blue and red intersect? Well, red, y is constantly 8. So if I plug 8 in for y, x is going to be a -7. -7, 8. Now, I would have to have some sort of objective function to analyze before I do anything with that. So all right. We're going to do one more here. We're going to call it a day with the notes. Number 1, in black, x is less than or equal to 3. So you got some product x, something x. Maybe it's a person, maybe it's a machine, maybe it's a product. It's got to be less than or equal to 3. All right, so straight vertical line, shading to the left. Then in red, I got y greater than or equal to -3x plus 9. There's 9, down 3 over 1, down 3 over 1, down 3 over 1. Definitely highlight the intersect there and there. I'm not going to change what I call it vertex 1, 2, and 3. It doesn't matter. All right, and I'm shading above the red line. So, okay, I can start to take, something's happening in there. And then lastly, I have y less than or equal to 9. Some other machine, product, person, 9 or less of that. Horizontal line shading below. They all come together. Here's my region of feasible solutions. So I could give an answer of this. That would technically satisfy it, but it's not going to maximize or minimize whatever I want. So that's first vertex is 0, 9. Vertices. The next one is, that's 3, 0. And this is 3, 9. And that is a good notes video for today. I will tell you, that's what we're going to start with on Friday. I will tell you to have this out and start working. The test date is most likely going to be Monday the 25th. Could possibly be Tuesday the 26th. We'll see. It's always been a pretty nice test. You want to start working. Imagine there's a test review answer. You're going to start working on this page. This is solving a system by substitution or elimination. Definitely do the first page. I believe I have to give you some answers for, I got to tell you how to do something like 9. But 1 through 8 here on the first 2 pages, try those. Try those. Okay, 1 through 8. Again, there should be a video online with these answers. We'll talk more about that in Friday's video. This is Yak Math Videos signing out.